An object is thrown vertically upward, and at these two times, t is equal to 1 second and 5 second, the object have same height, means same displacement from the ground, for example. Okay, before we solve this question, the one very important assumption that we are assuming, because this is vertically upward, so we can say it is the one dimensional motion. And which motion? It's a constantly accelerated motion or uniformly accelerated motion. In other words, you can also say it's a free fall motion. All right, free fall motion in which the acceleration due to gravity is negative g. So when the object is thrown upward, this is a ball which is thrown vertically upward with some initial velocity u. So what will be its trajectory? It will go vertically upward along y-axis like this, imagine, and then it will turn down and it will take same time to reach the ground because acceleration is constant. So let us say, for example, when the ball was at this point, okay, so let's say this was a t is equal to 1 second, or I should take here, and this is a time when t is equal to 5 seconds. So t is equals to 5 second here, and this is a moment when the ball was here at the first second. Okay, so because it's a uniform motion, uniformly accelerated motion, which means that at both of these points the velocity is same in magnitude but opposite in direction. Okay, because at all the same levels the speeds are always equal in free fall motion. So this gives us an idea that to find out the maximum height from our Suvat equations, what should we do? We can set two equations equal to each other. We can eliminate velocity because speed at the 1 second and the speed at the 5th second are both same. So you can see that their displacements according to the questions are same at these times. So s1 is equal to s5. So if we equate these two values, displacements, we can find out the initial velocity, and by finding initial velocity we can find out then maximum height attained by the ball. Okay, so let's start. So what is the s1? So we are going to use this equation, s is equals to ut plus half at square. So at 1 second, so displacement covered in 1 second is s is equals to u into 1 plus 1 over 2 into negative 10. We are taking the value of a negative 10 and 1 square. So that is u minus 5 meters is the distance covered, displacement covered in the 1 second. So displacement covered is s5 is equals to initial velocity same into the 5 seconds plus 1 over 2, a is negative g, which is negative 10, into the time square, that is 5 square. So it will become 5u minus 5 into 25, which is 5u minus 125. So these displacements are equal. Remember that I'm not saying distances are not equal, displacements are equal. So let's equate them. So when you will equate moving negative 125 to the other side, it will be 120 is equals to 4u, and u is equals to 30 meter per second. So finally we got the initial speed, and now we will utilize it to find the maximum height. Okay students, now we know that what is the initial velocity with which the ball was thrown upward, that is 30 meter per second, but still we don't know how much time will it take to reach the height, although maximum height, although we can find it, but we will not use any of the equation which will use the time, because we have already the data. This is a final velocity at the maximum height, that is 0. So you can easily use the another Suvat equation to find out the maximum displacement. So final velocity square is equals to 30 square plus 2 into, it's due to free fall motion, this is negative 10, and this is maximum displacement. Okay, so 0 is equals to 900 minus 20 into S max. So that will be 20 maximum height is equals to 900 and maximum displacement is 900 over 20, which is 45 meter. That's why our right answer is D.